we are supposed to find the current through R4. So when you have a problem like this, where you've got all kinds of resistors all over the place, the way you have to approach this is you have to start by simplifying everything down to get the main current, and then breaking it back out again to figure out what part is going through what. So the first thing that we have to do in order to do this is to figure out what is the total resistance of this this circuit here. What is the R equivalent of all of these resistors? So to remember to R equivalent, that if you have two resistors in parallel, R equivalent is product over sum. And you get so used to doing that that you can forget that that's only true for two resistors. So R equivalent for R3 and R4 is R3 times R4 over R3 plus R4. And you'll do that all the time. What you need to remember, though, is that, let's say I had, and at some point, someone will do this to you to try to catch you. If I had three resistors, then the way you find R equivalent is R equivalent is 1 over R1 plus 1 over R2 plus 1 over R3.
Why do you do it that way?
As opposed to what?
Like, why is it 1 over?
Because this is the real formula.
Okay.
It just so happens that it simplifies to product over sum if you have two of them.
Okay.
So could you do it 2 by 2?
And you can do it 2 by 2, which is usually what I actually do. What I do is I do product over sum for two of them, and then I do product over sum again.
I was going to ask that, like, if you do it that
Yep.
way. Okay, that's cool.
So R equivalent for R3 and R4. Redraw this circuit. Okay, so this is 560. This top one is 330. This bottom one is 330 times 560 over 330 plus 560. Which I do have written down, but just showing you how nice this one is. So 330 plus 560 over a product over sum. $330 times 560 over 330 plus 560. And it gives me a fraction, but I want that as a decimal, and it's 207.6. So just lovely little calculator. Okay.
When we're looking for sig figs, should we just do 1 or 2, or?
Sig figs never seem to be all that big of a deal.
She didn't make it very pertinent in the class, so I didn't think it mattered.
I usually keep a few extra just to make me feel good.
Right.
So I don't really pay much attention to it. Okay, and then with these two resistors are now in series, so we can just add them together. So I've got 560 here, and then these two add together to be 537.
And from there, can we just put
0.64.
560 and 537 in series again? I mean, in parallel?
We can. And so then the equivalent there is 560 times 537.64 over 560 plus 537.64, which is 274.3. Okay, and our total voltage was 5 volts. and that's over here. So now we can figure out the current coming out this way. So the current coming this way is going to be just using our voltage here and our resistance here. Then we can say I is V over R, which is 5 over 274.3, which is 0.0182 amps, or 18.2 milliamps.
Does it matter if we switch to amps and milliamps, or?
It does not matter. It does not matter. So I now know that I'm going to use milliamps just because I always look for the path of most laziness, and it's a little less to write to do the milliamps. So I've got 18.2 milliamps coming this way, and I see when it gets here, it has a choice. It can either go this way or it can go this way. So we're doing current division. And with current division, if I know the ohms on either side for current division, then I can figure out what part of the current goes one direction and what part of the current goes the other direction. So if I look at this one right here, where I have my 560 for R1, and I've simplified this whole branch into 537.64, then I can say I1 is going here, and I2 is going here. So by current division, if I want I1, I take my total current, which was 18.2, and I multiply it by the other resistance. So I'm looking for I1, which is going through the 560 ohm. I take the other resistance, which is 537.64, over the sum of the two resistances. So that's 560 plus 537.64. And if I do that, I believe I get 9.3 milliamps. Now, I don't know why, no, that's I2. I don't know why I said I wanted to find I1. I don't need I1. I1 is, well, I'll go ahead and find it. Let's see, let me do that. It was 18.2 times the other resistance, which was 537.64, over 537.64 plus 560, 8.91. Okay, so I get I1 is 8.91 milliamps. I didn't need that because my question is asking me for R4. But I found that instead of I2. I could have found I2 instead. But now that I have I1, I can get I2. I2 equals I minus I1. Because if 8.91 milliamps is going down this branch, then the rest of it has to be going the other way. So
Forgive me if I'm wrong, but, and you feel free to correct me, but I thought it was the total current times the resistor parallel over the resistor that you want.
Nope. It's over the sum,
The sum of.
the resistances.
Okay.
Yeah.
So we can still use the equivalent resistance for.
Yes, because it is equivalent. Because everything over on this side is as if it had,
It's running through all of that.
yes. And so I2 equals 18.2 minus 8.9, which is 9.3 milliamps. So we found that that's the part that's going through up here. It's the same that's going through R2. So we have 9.3 milliamps going to R2. And then when we get here, we're going to have current division again. And we want the current going through R4, because that's what the question is asking. What is the current through R4?
So would that be 9.29 over, would I instead of using the whole current, use the current that's coming from I2?
Correct.
Okay.
So I4 is going to equal 9.3 milliamps, because that's the current coming into that split, times the parallel resistor, which is 330, over the sum of the two resistances, which is 330 plus 560. And when you do that, you get 3.45 milliamps.
So with current division is typically used when, is it going to be used often with like when resistors are in parallel and stuff like that?
Yes,
Okay.
that's when you're going to use it, when resistors are in parallel. Yeah.
Okay. And then it's not really used outside of that, when outside of resistors in parallel.
Well, it's whenever the current is going into different directions.
Mm-hmm.
So whenever the current is splitting up and you need to find one part of it, and then hopefully you can find the equivalent resistances of the two paths that it's taking. But yes, that is what it's used for.